Physicists once believed detecting the graviton would require a machine the size of Jupiter, but a clever loophole may finally let us hear the quantum vibrations of space-time itself. For decades, the vast universe has played a complex game of hide and seek, with its most fundamental secret, the graviton. This elusive particle, the supposed carrier of gravity, is so small and so weak that detecting it should be truly impossible. Gravity is the weakest force in nature, making the graviton a ghost that passes through matter without leaving a trace. Physicists have spent years scratching their heads, realizing that our current technology is simply not sensitive enough to catch it. To find one using conventional methods, we would need a particle detector the size of a planet, a truly massive feat. Such a construction defies both our unlimited budget fantasies and our fundamental laws of engineering, making it a hopeless dream. It seemed the universe had built a wall we could never climb, keeping the quantum nature of gravity forever hidden. But just when all hope seemed lost, brilliant physicists have just found a clever loophole to bypass this impossible barrier. Instead of building bigger and heavier machines, scientists are thinking smarter, utilizing the subtle laws of quantum mechanics to their advantage. Enter the Resonant Mass Detector, a device designed not to catch the particle, but to listen to its subtle whispers. The core idea is to take a massive block of metal and supercool it to near absolute zero temperature. At these extreme temperatures, the thermal noise of the atoms quiets down, creating a state of near-perfect quantum silence. In this frozen state, the vibrations of the metal become quantized, turning into discrete packets of energy known as phonons. When a gravitational wave, which is essentially a massive flood of gravitons, passes through this block, something magical happens. The passing wave can kick a single phonon into existence, adding a tiny unit of energy to the silent system. This tiny event is the signature we are looking for, a microscopic footprint left by the elusive graviton particle. However, a single click is not enough. We need to verify this data by syncing with massive observatories like LIGO. By syncing this tiny click with the data from giant detectors, we can confirm the signal is truly from space. We might finally witness the individual quantum units of gravity for the first time in the entire history of humanity. But the universe doesn't give up its secrets easily, and there are still challenges that we must overcome today. Even if we hear that click, we face a haunting question. Is it truly a quantum graviton we detected? Or is it just a ripple in a classical field, mimicking the behavior of a particle without actually being one? To settle the debate, researchers are looking toward the optical Weber bar, a futuristic concept pushing boundaries of measurement. This device uses precise laser pulses to convert gravitational wave energy into permanent phase shifts within the light itself. We are no longer just observing the fabric of space-time. We are trying to catch it in the act. We are attempting to see the moment gravity behaves like a quantum object, bridging the gap between two great theories. The wall hasn't fallen yet, but for the first time, we can clearly see through the cracks in the barrier. This global effort combines the coldest materials on Earth with the most sensitive instruments ever built by human hands. Our quest to understand gravity is not just about physics, it is about understanding our place in this vast universe. As technology advances, these detectors will become more sensitive, bringing us closer to the holy grail of modern physics. Finding the graviton would complete the puzzle, uniting general relativity and quantum mechanics into a single theory of everything. It is a dream that started with Einstein and continues today in the coldest laboratories on the face of Earth. Understanding quantum gravity could unlock secrets of black holes, the Big Bang, and potentially interstellar travel in the future. The next generation of physicists is ready to take up the challenge, armed with new ideas and better technology. The universe is patient, waiting for us to develop the tools necessary to read its most subtle and ancient messages. Every interaction, every click, and every data point brings us one step closer to unveiling the ultimate reality. Imagine the headlines the day we confirm the graviton exists, changing our understanding of the universe forever and always. We are standing on the precipice of a new era, where the quantum world and the cosmic scale finally meet. The machines are running, the sensors are listening, and the scientists are watching, waiting for that one specific quantum kick. That single spike in the data will be the proof that gravity is indeed made of tiny, discrete particles. It will be like putting on a new pair of glasses, allowing us to see the universe in high definition. From colliding galaxies to the birth of the universe, the graviton holds the key to the past and future. Curiosity drives us forward, pushing us to build impossible machines to answer questions we once thought were unanswerable. We are small, but our minds can encompass the vastness of the cosmos and the tininess of the quantum. The hunt for the graviton is a global mission, uniting nations and minds in the pursuit of pure knowledge. Just as we discovered the photon is the particle of light, we will soon confirm the particle of gravity. We are writing the next chapter of physics, and the ink is the data flowing from these incredible machines. Success is not guaranteed, but the journey itself yields technologies and insights that benefit all of mankind today. Momentum is building, and the scientific community is buzzing with the potential of what the Resonant Mass Detector can do. The detector sits in the cold dark, a silent sentinel waiting to catch a ghost passing through the wall. A new dawn is approaching for astrophysics, illuminating the dark corners of the universe that were previously invisible to us. The math predicts it, the engineers have built it, and now we wait for nature to reveal its truth. Every great discovery propels us further, from understanding the atom to exploring the furthest reaches of our solar system. The very small and the very large are connected in ways we are only just beginning to truly understand. Data travels at the speed of light, bringing the secrets of the graviton from the detector to our screens. You are part of this journey too, witnessing the frontier of science as it unfolds in real time. With the help of advanced AI and supercomputers, we can filter out the noise and find the true signal. We are touching the fabric of reality, creating ripples of knowledge that will expand for generations to come. The universe is in our DNA, and finding the graviton is like finding a missing piece of ourselves. From huge detectors to tiny phonons, we have traveled a long way to catch the universe in the act. The wall has not fallen yet, but we see through the cracks. Thank you for watching Universe Secrets. Subscribe now